let Z be the standard, normal, random variable. Find, we've got a conditional probability here, find the probability that Z is less than 1.11, given that we know Z is greater than negative 1.43. Okay, let's copy that down. Less than 1.11, given that Z is greater than negative 1.43. Let's double check. Yes, we've got that correct. Okay. So what do we have here? Well, it's a conditional probability. So what we're going to do is we're first going to rewrite it as the probability of the intersection of these two events divided by the probability of the given event. So that's that second event here. Okay, so we want to work this out. Now, this bottom one here, the denominator, that's just Z compared to a simple value. That's something that we could look up, well, not look up directly in the table that we tend to use, but we can manipulate, we can use this table here to help us with the denominator. But what about the numerator here? It's an intersection. So we've got to sort of better understand what exactly is going on here. So let's just focus on the numerator, and then we'll bring it back and calculate everything at the end. We need to simplify and better understand this event here. Z less than 1.11, and, remember intersection means and, or you can think of it quite often as an and. Okay. So my Z values need to be less than 1.11 and greater than negative 1.43. If we wanted to, we could rewrite this slightly. Okay. Z greater than negative 1.43 and less than 1.11. So we write it a little simpler as sort of this double inequality or compound inequality here. But what does this really mean? Well, let's draw a picture. And I always find it's very nice to draw a picture to help visualize. So we'll get our standard bell curve. It's the standard normal random variable, so we've got a mean here of 0. Okay, and we've got 1.11 and negative 1.43. We'll just roughly put them on here. Okay, so those are the values that we're comparing Z to. We want to talk about the values of Z that are less than 1.11. So those would be the values to the left of 1.11. So just the probability here that Z is less than 1.11 would be this area that we've shaded. Right? So less than, so we think to the left. Okay? But we also want Z to be greater than negative 1.43. So those are values to the right. Okay? And so what do they have in common? What numbers lie greater than negative 1.43 but less than 1.11? Just the values in this range. So the probability of this intersection, which we've rewritten, is just going to be the area in between these two. Right? So we think through, we sort it out, we say, okay, I want this area here. How do I work out this area? Well, we can see that it is the area to the left of 1.11. Take away the area to the left of negative 1.43. Right? So this numerator that we need to calculate, we now understand we've got an area representing it. We can see it's a probability of, oh, well, this is something that can be very quickly looked up in the nice table associated to Z. And then, well, probability that Z is less than negative 1.43, that's not something we can look up in this table, right? The 1.11, that's going to be 0.8665. But unfortunately, we don't deal with negative Z-scores, right, with our table. Our table starts at 0.0 and only goes up. So we'll have to do a little bit of work. And we want this probability, but unfortunately we don't work with negative Z values. So what we're going to do is we're just going to flip everything over the middle line, the y-axis. And it won't change the area, and so it won't change the probability, but it will change our expression that we're working with, so that we get a positive 1.43. But now, of course, the area is going to be shaded over here on the right. Well, our table doesn't deal with areas on the right of positive z things. It deals with areas on the left. So we'll take the whole area under the bell curve, 1, and we will subtract away the area on the left. And that, at least, is something that can be looked up. Okay. So 1.4 and then 0, 1, 2, 3. So it'll be 1 minus 0.9236. Okay, so that'll be 4670. 0.0764. So that needs to be taken away from 0.8665. And that, at long last, will give us the numerator that we need. And then we'll work on the denominator. Okay, so what was it? 0.8665 minus 0.0764. Okay, 5 minus 4, 1, 0, 16 minus 9, and 7. Okay, so the numerator is going to be 0.7901. Okay, so the probability we want looks like 0.7901 all over, and then what was it that we needed? The probability of the known event. We know that z is greater than negative 1.43. Okay, what is that probability? Well, again, we don't deal with negative values for our z, comparing z to negative values. So we draw a little picture to help us understand. Now we want greater. So that's the area all over here. Still, we need to flip things over. All right, flip over the y-axis to change negative things to positive things. So the negative 1.43 becomes 1.43. This area that was shaded all on the right flips over and now is shaded on the left. So this denominator is the same probability as something that we can actually look up. It's the probability of z being less than 1.43. We already looked that up. I don't remember it off the top of my head. So there it is, 0.9236. Okay. And that's going to be our denominator here, at least working to 4 decimal places, right? .9236. Right? So there we go, although I wouldn't leave it like that with the decimals. I would probably say, let's clean this up a little nicer, say, all right, z being less than 1.11, given that we know z is greater than negative 1.43, is, so I can write this as 7901 over 10,000, all over 9236 over 10,000. Right, just rewriting these decimals as fractions. Right? If we go to 4 decimal places, just write those 4 digits over 10,000. Right? And then we can flip the bottom one and multiply, or you can just say, well, the 10,000s here cancel out. Okay, so 7901 over 9236. It doesn't look like those are going to simplify, so I'm just going to leave it as is. You know, maybe there's a factor of 7 or something that I'm missing, but I think we'll just leave it as is.